Okay, thank you. All right, so welcome everybody to our second GKS open house. I'm Alex Wagner. I'm one of the workstream co-leads. Melissa Klein was unfortunately unable to join us today due to a family emergency, but she sends her um, well wishes for the presentation and wish she could be here. And I'm sure she'd be happy to take any follow-up questions if you have some specifically for her. Okay, so that said, let's go ahead and dive in. So, first of all, welcome everybody. The idea of our open house sessions is to really give people a very high level picture about the work stream, about the things we're doing, and provide a forum where you can ask questions, get engaged. We invite different participants from the community to talk about the work they're doing and how they're applying GKS standards to solve real world data problems. So that's what we've got on the agenda for today. Um, but just as a note, this is our second time doing GKS Open House. We're still kind of testing out the ropes here. And as I mentioned, we're sharing live implementations, product progress. And we're trying to keep this really high level. And we try and feature one of our products in each one of these, which we do infrequently enough that that's more than ample time to get substantial updates between them. So today we're going to be talking about our variant annotation spec or VA spec product. We're going to be talking about how ClinGen's implementing it as well as the Vic driver project. Okay, so a bit about what GKS does. We spent a lot of time thinking about the bottlenecks in variant interpretation, the way that we take evidence that's provided by a bunch of different heterogeneous resources, bring it all together and use that to drive variant classification. And, here we have our frustrated variant scientist who's trying to pull together some predicted impact stuff from VEP, which is on, from a VCF, an annotated VCF file. They're pulling together HGVS annotated clinical reports with a transcript context, some information from the NOMAD resource, which uses like a VCF derived nomenclature for background population data, and then some functional data from MaveDB, which is in its own custom format that's needed for that resource and that evidence. And they have to pull all this together and make sense of it. And it's a big challenge. It takes a lot of time. So our goal in Genomic Knowledge Standards is to help alleviate this bottleneck through development of standards that allow us to translate information across a federated variant evidence ecosystem. And where that evidence in these resources is disparate in its structure, it's fragmented in its context and distributed across all these different locales, our solutions must interoperate across those data structures and be self-descriptive to allow us to understand the context from which they originated, as well as be globally consistent in a federated data ecosystem where we can't expect every resource to coordinate with every other resource to make sure they're all expressing the same data in the same way. And of course, we expect that this challenge is going to continue to grow. We've seen, great advancements in the Human Pangenome Project and the Telomere to Telomere Consortium, the Atlas for Variant Effects Alliance, and other community-specific resources like those hosted by the DDBJ. And as these come online and as they gain greater adoption in the genomics community, we need to be thinking about how we translate evidence and information across these contexts effectively. And when I talk about genomic knowledge, it's quite complex and varied, but it generally resembles these types of statements. Huntington's disease appears fully penetrant among patients with polymorphic trinucleotide CAG repeats with a count greater than or equal to 40. It's an example of a pathogenicity statement from the ACMG guidelines for clinical laboratories. You could also have functional knowledge statements about MAVE experiments, or you can have therapeutic response type evidence and knowledge that comes with how different therapeutics are used to treat patient tumors in the presence or absence of specific activating mutations. And so in order for us to be able to represent all that complexity across all these different scopes, we kind of focus on three different areas of knowledge representation. There's variant representation at the base, which tells us about the variants themselves. There's variant annotation, which is the primary topic for today, which allows us to combine the evidence associated with those variants into larger, more complex knowledge structures and give us N classifications used for interpreting those variants. And then finally, sequence annotation, which is still in its study group phase, but is a way for us to think about the various features that we annotate a genome with, like exons or transcripts or genes, and how computers talk about these and relay information about them. Now, to that end, we have multiple products and study groups. Some of these are completed. So our categorical variation study group, for example, completed towards the beginning of last year. And it's currently in its final prep for release in June 2025. So that's, of course, I guess that's this month. Here we are on June 2nd. So, this month we have CatVerse coming out as well as VA Spec. And of course, earlier this year, we saw verse 2.0 approved and released by the GA4GH. So we've got a lot going on. We have our sequence annotation group, as I mentioned, as a study group, and they're planning to release their recommendations towards the end of this year. And all of these different standards you benefit from and are driven by the involvement of many current and ongoing implementations. Here are a few different communities and specific resources that are contributing to the development, design, and testing of these specifications. And collectively, they produce the expertise necessary to create interoperable and exchangeable knowledge. The way that we work with these implementations is we have a formal implementer registration and polling process where when we have a specification that a group is interested in using, they'll register as an implementer. And then when we are thinking about feature design and development, we will poll those implementers to ask their opinion on the use of these. Then we use that data to drive feature development. So we're focused on what are the features that are going to be of greatest impact to the community, and do we see these as existing necessary gaps to drive implementation? Okay, so that in a nutshell is who we are and how we operate. Before we dive into VA spec, I thought I'd just pause here for a moment and ask if anyone has any questions about the overview of GKS.
Folks can put questions in the chat too if you're not comfortable speaking up. This
Yeah.
really is.
Hello. Um, I've already unmuted. So, hi. Can you hear me?
Yes, we
Yes.
can.
Yeah, thank you so much. That was very insightful. My name is Mohsen. I'm based at Stanford, and I do also do a small startups, being doing more proactive medicine by using the genetics and genomics. And it's absolutely a must need to my understanding. But I'm very new to this and kind of interested to know more about the other, EHR providers like, Oracle, Cerner, and tons of many others. And if you don't mind, probably I've been missing this. I'm pretty sure have been discussed, but if you don't mind, can share a little bit, would be very helpful. Thank you so much.
Yeah, it's a great question. I think we'd love to see more community engagement from other EHR providers. Not all of them are, moving as rapidly into, the genomic knowledge sharing space, which is a very specific domain. From the EHR providers, the one that we have most directly engaged with our product is the Epic team. So Epic has a genomics team, and they've been very intimately involved in how they use these standards for both pulling in information from their consumers at the assay level, but also from knowledge bases and harmonizing that internally so they can then provide that knowledge back to their consumers. So, most of our engagement in that space has been with Epic so far, but yeah, we would love to, of course, see participation from other vendors as well.
Thank you so much.
Okay. Now, as Angela said, feel free to drop questions in the chat as we're going. and we will pause and provide answers as we're able to. And there will be breaks in between each section where we can also just pause to make sure that people do have some of that breathing space to get their questions out. All right, so with that, I think I will turn it over to Matt. Matt, I'm happy to drive here. You just want to say next, I'll flip through the slides as we go.
Sure. You can go ahead to the next one. Just say I'm Matthew Brush. I am the lead of the VA spec development working group, along with Larry and Alex, who've been kind of temporary co-leads as we get this up and running. And excited to talk about the spec that will be released later this month. VA spec, it provides a set of schema for exchange of knowledge about genetics variation and also the evidence and provenance information that supports that knowledge. Each schema in this set of schema is built as what we call a profile that extends a common domain agnostic core model to support a specific type of variant knowledge. We saw examples of these types like pathogenicity, functional impact, therapeutic response associations. And importantly, these schema import and reuse existing GKS standards like VERSE and CATVERSE, which are used to represent the variation concepts that VA knowledge reported in VA spec data is about. And another important kind of detail here is that the development and the release of VA models is really driven directly by these implementations that Alex talked about, by driver projects and community adopters that are shown on the right there. So this means that all the modeling that we do is really driven by implementation use cases and tested in working systems before it's released. And all the classes and attributes in version 1 of the model that's coming out are being actively used to collect data by one or more of the projects here. Next. So the first release of the VA spec will include these components, again, foundational domain agnostic core data model. Again, that is kind of the basis on which all these domain specific profiles are built. It will include this set of profiles for representing specific types of variant knowledge or evidence. These will be provided as JSON schema for use by the community. And on the right, we see a catalog from our documentation of the schema that will be included in this version of the spec. And we'll talk a little bit more about some of these later. And then the spec also includes a Python reference implementation that will support creation and validation of VA compliant data. Next. So a little bit about each of the core components now of the spec, and I'll start briefly with the core data model. This diagram is just shown for reference. It shows kind of a hierarchical overview of the classes in the model to give you a sense of kind of its breadth and scope. You can go to the next slide, which is a more interesting kind of view to think about, which is the types of data structures that these classes support and can be used to build. So the kind of core data structure that we see the VA model being able to build is shown here on the right. And it consists of this central repeatable axis that connects what we call statements to evidence lines, and then evidence lines to evidence items, which are things like study results that represent kind of the foundational data that gets used as evidence for those higher order statements. So these statements are where we capture knowledge that's asserted about a variant, and also any report about the strength or confidence level of that knowledge. So these may, report things like, right, a particular HRAS variant is causal for Costello syndrome, and that this is kind of something that we have very high confidence in. Statements may be supported by one or more evidence lines, which is the next kind of class there in that central axis. These evidence lines specifically describe how information from something like a study result or a prior statement, how that information was actually interpreted as evidence to generate the knowledge reported in that root statement. Does the evidence support or refute that statement, and how strongly? How was it interpreted, when, by who? So the example here, right, that evidence line might say that a particular set of population frequency data provides moderate evidence that supports this fact that's asserted by the statement above it about the pathogenicity of that HRAS variant. And then these evidence lines, in turn, may be supported by one or more what we call evidence items. Here, the example is a study result that reports the actual population frequency data that was used as evidence in this particular example. The additional classes surrounding this central axis are there to provide detailed representations of the provenance of each of those central artifacts. So we can describe methods that were used to generate them, documents where they're described or published, and contributions to them made by different agents. And if you pop to the next slide, Alex, I just want to highlight that you note that statements and evidence lines, oh, one back, both contain, yeah, it just was kind of an animation there, both contain a proposition object. And these propositions are what we use to express the semantics of the possible fact that's asserted by a statement or the fact against which evidence is evaluated in an evidence line. So encapsulating this shared meaning across statements and evidence lines kind of gives us a way to reference and reuse that single proposition in these different contexts and link data in that way. So you can go on to the next slide now, Alex. So that's a little bit about the core data model and the structure. It will become, I think, relevant when we see some of its application in the civic data later. So I wanted to just give that background. And again, this core data model defines those foundational structures and semantics that underpin all the specific VA profile schema, which adopters will actually use for representing their data. So these profiles import and specialize that core model so they can build structures like the ones that we saw earlier, but with constraints that tailor them for a specific type of knowledge or a specific community guideline. And as a kind of concrete example here, the figure illustrates specializations that were applied to derive the variant pathogenicity proposition schema from that core proposition class. So we can see how in our domain agnostic proposition class, we have attributes like the subject and predicate and object, and those get specialized in our profile to take particular data types, and they get extended with some qualifiers that are relevant for that particular type of statement that may apply a gene context or allele origin kind of qualifier that's important to really represent the full semantics of a variant pathogenicity proposition in particular. Next slide. And this figure similarly shows specializations applied to derive an ACMG aligned variant pathogenicity statement profile from that core statement class. Again, similar idea here, layering onto these constraints on fields like classification that bind them, in this case, to specific values based on ACMG terminology. And we'll go a little bit more into that community profile idea, I think on the next slide, Alex. So we call these profiles, no, first I'll just describe the different profiles that we are releasing as version 1 of the spec. We have variant pathogenicity statement and evidence line profiles that are aligned with ACMG guidelines. We will have variant oncogenicity statement and evidence line profiles that are aligned with CCV guidelines, therapeutic response, prognostic, and diagnostic statement profiles that are aligned with AAC guidelines, and then cohort allele frequency and functional impact study result profiles that are used to describe the more foundational evidence used to support these higher order clinical classifications. Next. As I noted, we call these profiles that align with conventions of established community guidelines, community profiles. And at present, we have community profiles for the 3 guidelines that are listed here that I mentioned in the last slide. And then the table below just shows a concrete example of how the classification attribute in this case in different statement profiles is constrained based on guideline terminology used in their respective domains. So for a pathogenicity profile in the top row, it takes values defined by the ACMG guidelines, as you see there. For an oncogenicity profile, that attribute is constrained to take values from the CCV guidelines. And similarly for therapeutic response, it takes values defined by the AAC guidelines. So again, this is how we can provide sets of profiles that are all aligned with terminological conventions from a particular community for users that want to align with those conventions in representing their data. Next. So I'll wrap with a quick overview of implementations and use cases and a couple future plans. This is just a list of registered implementation projects for the VA spec. The top 3 in yellow are ones that have current working implementations. And importantly, I think 6 of the remaining 10 on this list are actively developing implementations in collaboration with the VA team. So there's a fair bit of momentum here for using the spec that we want to kind of keep pushing forward on. Next slide. These are just a few examples of variant knowledge exchange scenarios that are being implemented by these projects. The first is a service that we'll hear more about later today for submitting oncogenicity classifications from CIVIC to ClinVar. The second scenario describes a pipeline where ClinGen and the VIC MetaKB systems will ingest pathogenicity and oncogenicity classifications and evidence from the GKS ClinVar implementation. And then the third describes a pipeline where Epic will ingest various clinical significance and functional classifications from sources like ClinGen and VIC MetaKB and MaveDB that are all using the VA spec to exchange and retrieve that data. And these last two implementations are close. I think they're still in the works, but will hopefully be up and running soon. Next slide. And I also want to show kind of a grander vision here of how statement and evidence lines and study result profiles can really be used together to assemble evidence from different systems and structures in support of things like variant classification. So I wanted to highlight that the profiles I'll show in this example are all ones that are released here, highlighted in yellow in this the spec that's coming out this month. Next slide. And then in this, again, currently aspirational scenario, evidence from MaveDB and Nomad systems, those are highlighted in yellow and green respectively, can be retrieved through VA compliant APIs into a system like ClinGen, where curators might want to use that evidence to create a pathogenicity classification. So really the goals of this slide here are kind of twofold. The first is really to highlight the detailed structures that VA models can support. So in this example, if we start at the bottom, right, MaveDB in yellow there, in their system, they're producing functional impact study results that describe the more foundational functional impact scores that they generate through their high throughput pipelines for different variants. And then they're using that and interpreting that as evidence for statements or classifications of those variants. So that statement, the second statement on the left there, which is, right, based on those study results, we want to classify that this variant is abnormal, has an abnormal kind of functional impact on the gene. And they also produce evidence lines that interpret the direction, the strength of evidence that they believe that that classification has for or against the pathogenicity of that variant. So all of those data structures that we see in the yellow box at the bottom are being produced by Mave and generated in VA compliant forms that can be then retrieved by the ClinGen system in blue. And similarly, Nomad data, in this case, cohort allele frequency study results, reporting various frequency measures of a particular variant in different populations, also being produced in VA compliant form, also able to be kind of retrieved into ClinGen systems. In that case, it's the ClinGen curator who is going to interpret the evidence line there that data provides evidence for or against the particular variant that they are classifying. And all of that really comes together because of this shared model, and the computational possibilities that may support are really what is exciting to me, right? So with a standard like VA spec as a basis for shared exchange pipelines, we could really create services that assemble evidence into structures like this in a very automated and scalable way. So if we have a curator who's working on a variant of uncertain significance for a particular condition in ClinGen, right, we could develop tools very easily now that could match their variant and condition of interest to relevant evidence of different kinds across different systems, and then automatically pull that evidence to automatically create these standard structures like the ones we see here. And that could be used then to populate curator interfaces to kind of facilitate manual curation, or even drive automated classification algorithms that rely on this kind of standardized data to reach a definitive classification for that variant in a much more kind of rapid and efficient way. So that's the vision we ultimately want to support. I think the next slide is my last, which is just a few of the one more. few of the future plans here. Again, a lot of momentum right now, I think, among adopters and implementers. We have a set of new profiles in the works that we're going to be adding to the list that are shown there. Again, some of these implementers that we're working with to develop their own implementations that should be coming online soon. Working on a lot of documentation improvements. We'll be interested in the feedback we get after the first release of what would improve kind of our documentation for different user communities, and exploring more technical mechanisms to support better community-driven profiling efforts, to kind of take this profiling framework that we developed and make it easier to implement by a wider community of experts. So we remove any kind of central bottlenecks and allow expertise from the whole community to really go into to creating these profiles. So I'll stop there. I think that's my last slide. And Alex, if you want to pause for questions, I'm happy to take any of those.
Yeah, absolutely. Questions about the VA spec that Matt can address? Okay. Well, if the questions occur to you down the road, please do just enter them in chat and we will get to them in the order they're received. Also, feel free to raise your hand at any time and we can pause if you get lost or have questions along the way. Okay, so with that, I think we'll move on to our VA Spec driver project applications. First up, we have Larry Babb representing the ClinGen driver project.
Yes, just wanted to give an update. I started this project quite a while ago, or we've started this project quite a while ago for ClinGen. I'm a driver project champion for ClinGen, and I assume folks know what ClinVar is. But we decided quite a while ago that we needed to create a bunch of data sets in using the GKS format. One, to sort of prime the pump, show people what's possible if we had some of these data sets built, like Nomad, ClinVar, Civic, MaveDB, VEP, and things of that nature, that folks would naturally start wanting to use them and pay attention to these schemas and specs. So this ClinVar GKS pipeline was born out of the idea of really enhancing the utility and accessibility of ClinVar datasets within ClinGen, but also to share outside of the ClinGen community. So we decided to develop a data transformation pipeline. As ClinVar releases their XML data sets weekly, their dump of their database, we essentially output them in these verse, catverse, and VA profiles that you've been hearing about. We're doing it for the SCVs, RCVs, and VCVs, and they'll come out as JSON files. This is still a work in progress. We're very close to being able to have some early adopters work with this. That'll probably be happening in this month. ClinGen is participating as a driver project to do this. The reason it's been taking a while is because we've been piloting this work primarily around the variant pathogenicity statements that are in ClinVar, even though now they're supporting somatic, oncogenicity, and the therapeutic response and some of the other ones that you saw. But it was a lot of work to co-work with the VA spec group, Catverse and Verse, to find all the changes that we need to the schemas to make this work. So that piloting process is done with these releases you've heard about. We're now in the QA test for the pipeline to get it in production use and trying to implement it as a single standardized source for the ClinGen ecosystem. Next slide. This is the ClinGen ecosystem, and just to give you a real high-level view, there's a lot going on there. These are the groups that we support: the variant curation expert panels and genome curation expert panels in ClinGen for rare disease. They use tools by the Stanford team, the variant curation interface and gene curation interface, and the Baylor team that supports a lot of the infrastructure around the ClinGen allele registry, the linked data hub, the criteria specification registry, the evidence repository, and the overall ClinGen data exchange ecosystem, which connects a lot of our infrastructure with a streaming pipeline, a streaming service. All of these ones that I mentioned. There are other ones in the ClinGen ecosystem, but these are the main ones, and these are the ones that are going to hopefully be impacted by the use of this single standardized real-time source of ClinVar data that we're trying to produce. We're also working with other early adopters. As you heard prior, Epic, MedicaB, the Civic Group, Mave and whatnot. Lots of folks have shown interest when they've heard about this ClinVar GKS format and being able to get a hold of it as either a file download or a streaming service. And we're trying to figure out how we're going to make that more available to a wide range of the public. And we're working with NCBI and ClinVar to keep them involved so that if there is mass need for this kind of a thing, maybe they'll just take this service over themselves and produce it directly. Next slide. This is just giving you an idea of some of the complexity in the current releases. I just grabbed a release from March 23rd. Sorry, this is not updated to the current date, but I just sort of put this together sort of quickly right before this. There are over 3.46 million different categorical variations in the March 23rd release. It's up to 3.7 now, I think, in June. There's 33 million plus unique HDVS expressions across those. And as you can see, within there's not just canonical alleles, or what we call canonical alleles, 3.37 million, which is the bulk of them, but there's also copy number variants, like categorical CNV changes and categorical CNV counts. As you're seeing over to the right, that table represents the different amount of categorical variants in ClinVar. So just wanted folks to get a sense that it's not just one kind of variant. As far as the statements in ClinVar, there's lots now. They've introduced the oncogenicity and somatic. They're just starting to come in. Again, these numbers are from March. Those numbers are definitely higher now, but the very small amount of somatic, but we expect that's going to increase fairly rapidly over time. But the bulk of it's in the germline disease area, where the bulk of the submissions to ClinVar for variant pathogenicity, there's over 5.1 million statements there. And what we decided to do on the right at the bottom there, what you're seeing is a count of all the different germline or all the different variant pathogenicity, or not variant pathogenicity, SCV submission types. And if you go down that list and you take out variant pathogenicity, drug response, oncogenicity, and somatic clinical impact, that's all falling into the other category. And the idea there is these are sort of pretty old kinds of submissions that people don't put in anymore, but they're still out there. So we're going to throw those in a bucket and make sure that they're available. And the goal of the ClinVar GKS is to provide exactly what's in ClinVar, not to change it or fix it. I mean, that's up to ClinVar to do that and the submitters, and we work with them on other projects to do that. And that's it.
Okay. So in the interest of time, I think we'll save questions on that and then these next few slides together. But I want to talk a bit about a related project we've been doing on representing knowledge from the Civic platform using the variant annotation specification. So for those of you that are less familiar with Civic, Civic is it's a knowledge curation platform for interpreting variants in cancers. And it's designed to work through a curation cycle where we have community curators that come in and provide evidence about the role of variants in cancer diagnosis, prognosis, treatment, and progression. And also will provide some, context around how these are then used in professional society guidelines. And we'll talk a bit about that a bit later. But in short, those curators, they come in, they provide this information. Anybody in the community can do it. All the content submitted to Civic database, the Civic knowledge base is CC0. It's public domain, so there's no restrictions on the reuse of the data that are submitted into Civic, which makes it very accessible for downstream resources and tools. Now, the other part about Civic is that we also have a community of expert editors. These are people that review submissions from the broader open curator community for accuracy and completeness, and ensure that the content is of high quality, and those get approved by the editors or reviewed, revised, or rejected by them. And then that approved evidence is used to help interpret variants in downstream precision medicine workflows. And the core goal of Civic is to really help us go from kind of the raw text and images in a manuscript describing the role of a variant in driving cancer or in the treatment of cancer, and be able to translate that into a standardized data structure that allows us to capture the evidence associated with that variant and its role in cancer treatment or progression. And we use a structured data model to accomplish that, which includes information about the variant, the tumor context, any associated phenotypes, the clinical significance, the origin, meaning is it somatic or germline, or some sort of common germline mutation, as well as any associated information such as the clinical trials registry number, sort of a quantitative assessment of the thoroughness of the study, and then, of course, a short human readable description summarizing that evidence. This evidence exists across many different types. So we have, things that describe the role of the variant in predicting the growth and development of a tumor or oncogenicity, as well as predispositions. These are typically germline variants that can cause a cancer to develop in an otherwise normal, healthy individual. Prognostic variants, which tell us kind of what the likely outcomes are for a patient given the presence or absence of a variant. Diagnostic, which helps us determine what particular type of cancer you might be describing based off of the presence or absence of variants. And then finally, and most frequently, therapeutic response predictive evidence, which tells us about the role of a variant in either generating sensitivity/response, or alternatively resistance to a therapeutic based off the presence of that variant. Now, each of these have multiple directionality. We could say that evidence either supports or does not support those conclusions, and it comes across a variety of different levels, which are a way of basically saying what degree of authority or weight should be put behind this evidence. Everything from inferential evidence, where there's no direct measure, but there's evidence to suggest that a variant has a role in one of these types, up through validated. And this is like professional society guidance on how you should interpret variants. And so these different levels are applied to each evidence record across these different types, which you've already discussed, and constitutes the majority of the content in the Civic database. Now, importantly, what we want to do is then apply that evidence in the context of professional society guidelines for how you interpret variants based off that evidence. And in the cancer space, there are two major guidelines that we think about, which are the ClinGen CGC Vic guidelines for oncogenicity, as well as the AMP-ASCO CAP guidelines for clinical significance. But then I should highlight there are many others, and some of these we also capture in the Civic knowledge base. We have expert groups that are involved in the ClinGen somatic ecosystem, for example, that have their own guidelines that share some of the same characteristics, maybe the same classifications, but have different criteria by which you generate them because they're based off a different type of variant, such as fusions, which are quite common in the somatic cancer space. So we needed a specification, a standard that allowed us to kind of describe evidence and knowledge generated from that evidence across all these different types, and that's what we use VA spec for. And these high-level assertions that capture this look like this, and Basically, it's a summarization of evidence and then any applicable codes or classifications as provided by different community frameworks supported in Civic. Now, importantly, one thing that we are working towards and are releasing this quarter is the notion of endorsements, where we can have expert communities come in and say, yes, this assertion is something that we say has followed our processes and is therefore part of our expert guidance to the community about this variant and its role in, oncogenicity or therapeutic response or some other assertion type. And this gets displayed very prominently on the assertion page when it exists. And once we have endorsements, our plan is to then have those submitted into the clinical record, or excuse me, disseminated out to other different resources, such as ClinVar. And to talk about some of our work doing that, Corey Kuzma is going to be describing our work on the GKS ClinVar this project. And Corey, I know I saw you here earlier. You still here?
Can you hear me okay?
Yes.
All right, cool. Yeah, I'm Corey Kuzma, software developer in Alex's lab. I'm excited to have the opportunity to share the work I've been doing to submit VA spec formatted data to ClinVar using the GKS ClinVar this tool. As we just heard from the updates from everyone, VA spec has evolved and it has really helped standardize submissions in this tool. Next slide. So just a quick outline, I'm going to talk about the motivation behind this tool, the different ways to submit to ClinVar, how we represent civic data using GKS, and more information on the state of the tool and how it's being used in the civic workflow. And then I'll end with next steps. Next slide, we can go ahead and skip this since ClinVar has been talked about. And as mentioned before, the somatic, the ability to support somatic cancer variants was just released this year. The Civic team worked really close with Melissa Landrum and the team at ClinVar to do this. So next slide. And here's just an example of a somatic submission in ClinVar submitted by Civic, which was actually the first group to submit somatic variant classifications to ClinVar. And it's important to note that this submission was done manually using spreadsheets, which I'll talk about more later. Next slide. The main goal of this project is to create a GKS-based ClinVar submission utility tool. We want to be able to submit GKS VA spec formatted data to ClinVar using the ClinVar submission API. By using the GKS formatted data, it will allow us to standardize the submission process, which means submissions will follow a consistent format, reducing manual effort and therefore errors. And by leveraging the submission API, it will make it easier to automate submissions, which will make the submission process more efficient and scalable in the future. Next slide. So one aim of the NCI Biomedical Knowledge Base Award is to submit SCV-SEP curations to the ClinVar resource using this new somatic variant model. And at the moment, Civic submissions to ClinVar rely on a semi-automated submission form process. So my first objective is to submit Civic GKS formatted data to ClinVar and fully automate this process. I'm going to focus on the AMP-ASCO-CAP 2017 community profiles. And just as a reminder, this is the therapeutic response, diagnostic, and prognostic study statements. I'm also going to focus on submitting new or novel submissions to ClinVar. In the future, we'll add support for updating and deleting SCV records. Next slide. So now that I've given some background information and the goals for the project, I want to dive a little deeper into the different ways to submit to ClinVar. Next slide. So there are currently 3 different ways to submit to ClinVar, the first being through the submission wizard. And this is the simplest way to submit single variant classifications to ClinVar. It really walks you step by step through the submission process, and it can be a good option for those with no informatics experience. However, it doesn't handle all types of submissions. For example, you're not able to update a previous submission using the wizard. The next option is submitting via spreadsheet, and this is the most common way to submit to ClinVar. There are 3 Excel spreadsheet templates available for germline and somatic submission, supporting both minimal and detailed submissions. Submitting via spreadsheets, it is recommended for batch submissions and requires some informatics experience. However, this is still a manual process with limitations to automation. And the last way to submit to ClinVar is through the submission API. And this is the best option for automating submissions. However, it does require the most technical expertise and understanding of the ClinVar API schema. The ClinVar GitHub repo actually contains sample submissions, and it was really nice to kind of get an idea of the data in the format that I could submit. Go ahead and click for the animation. Nice. In the submission utility, we'll be using the submission API since it will allow us to fully automate submissions. Next slide. So some prereqs that you should be aware of when using the ClinVar submission API is that you must first register your organization, and anyone who submits to ClinVar must do this. The last two are specific to the submission API. So you must contact the ClinVar team to request a service account. And once you do this, you'll want to generate an API token. This process is really well documented in ClinVar. And for me, it was a pretty simple and quick process to get this set up. Next slide. The ClinVar submission API also provides some nice ways to test submissions before submitting to production. So first you can perform dry runs, and this is good for testing the JSON format, but it does not do any data validation. Oh, sorry, I skipped. Did it skip the... Oh no, I skipped it, sorry. Sorry, the three main operations when using the API are to create the SCV record. And this is again, just the submitted record in ClinVar. Next is to update the existing SCV record, and you can update any data from the submission. You can also delete the SCV record. Next slide. Now this is for the test submission. So like I said, the dry runs, you can test using the JSON format, or dry runs, yeah, to test the JSON format. And the test endpoint, this is if you do want to perform some basic data validation. And this is recommended for, they recommend testing novel record submissions due to the test environment. And it's also worth to note that there is no test user interface to see what a submission would look like in ClinVar. It's really just JSON format that you get to see. Next slide. So now that we understand the different ways to submit to ClinVar and more specifically information on the submission API, I want to talk about how we represent civic data using GKS. And I want to give a big shout out to Susie and Adam from the Griffith Lab for their support with this. Next slide. We can skip this since Alex just went over that. And I think we can skip this too, because I think you talked about it. So at a high level, this figure shows the structure and relationships for a civic predictive assertion using VA spec. What's nice about VA spec is that you can programmatically create these nice human readable statements. So EGFR supports a strong clinical significance classification for sensitivity to afatinib in lung non-small cell carcinoma. Next. So EGFR, this corresponds to the gene context qualifier. Next. For supports, this comes from the variant therapeutic response study statement direction. Next. And with the classification and strength, you can construct the significance classification. Next. The sensitivity comes from the proposition's predicate. Next. The drug comes from object therapeutic. Next. And the disease is just the condition qualifier. Next. All right, so now I want to introduce you to CivicPy, which actually I believe was developed by the one and only Dr. Alex Wagner. It's a Python software development and analysis toolkit for the Civic knowledge base. And the main functionality is to extract records from Civic, convert them to Python objects, and provide tools for exploring and analyzing these records. One of the cool things about it is it's quick retrieval via local caching, and a nightly cache is hosted on the Civic server, which is built using CivicPy. And it also has these exporters, one being able to represent Civic records as VCF files. Next slide. So one feature that I added to CivicPy was the ability to do the mapping that we just kind of talked about, which is representing a civic assertion using the VA spec and AMP-ASCII-CAP 2017 community profiles. And in CivicPy, if you're looking through the code base, this lives in the exporters module. For this, I had to add VA spec Python as a dependency. And this is just the Python reference implementation for VA spec, which is primarily used for creating Pydantic classes for validation, and it supports all the classes in VA spec. This allows us to inherit the corresponding Pydantic models to ensure that we're representing the community profiles correctly. And there's also functionality to write these records to a JSON file, which will be used later on in the GKS ClinVar tool. Next slide. You can use CivicPy directly from the terminal with built-in command line utilities. And another thing that we added was a new command to create JSON files for civic assertion records endorsed by specific organization that are ready for ClinVar submission, represented as GKS objects. Alex gave a brief overview of these endorsements. Go ahead. So now that we have a way to represent the AMP-ASCII-CAP 2017 community profiles in Civic, we're now ready to submit this information to ClinVar using the submission utility tool, GKS ClinVar this. One of the first things that you do whenever you're working on a problem is, has someone already solved this for me? Next slide. And after a quick Google search, I stumbled upon varfish.org/ClinVar this, and it's a Python-based software for the easy submission of variants to ClinVar. It provides both a Python API and command line interface. It already leveraged Pydantic, which is a big one for us because we love Pydantic for its validation. And it's pretty well documented, which is always great when getting familiar with new tools. Most importantly, ClinVar this had all the submission work done for us. We're able to configure our API token, submit batch submissions to ClinVar, perform dry runs, and use the testing API. So assuming you've configured your API token for your organization, the workflow is pretty straightforward. Next animation. So first is creating a file for import. Originally, ClinVar this only supports TSV files for import, and it's well documented on how to format the TSV for the sequent variant or structural variant submissions. Next slide. Or sorry, yeah. ClinVar this batch import, this will import data for a new or existing batch from that file that you imported. Next. ClinVar this batch submit, this is, it will submit the given batch to ClinVar. Next. ClinVar this batch retrieve, it will allow you to retrieve the status of the batch. So seeing if it was a failure or a success. And you keep repeating this command until you get one of those statuses. The other status is in processing. ClinVar this batch export, this allows you to export batch data to a given file. And ClinVar this ClinVar this provides logs and output files in this workflow. And it's really nice to have this data persist. We actually reached out to the maintainers of ClinVar this to see if they were willing to collaborate on supporting semantic variant submissions to ClinVar using GKS, and they were actually open to collaborate. One thing that was really nice is that they added support for semantic submissions for us, so it was a no-brainer to leverage this work. All I needed to do was add the GKS transformers, which take GKS formatted data and convert it to the format required by the ClinVar submission API. Next slide. Due to time, this is just where work lives. Latest branch is issue 4. Next slide. So I've extended ClinVar this to support the GKS JSON as a new file format in addition to the original TSV files that I was talking about before. We have a child class which inherits from this GKS JSON transformer to support the AMP-ASCII-CAP 2017 community profiles. This will allow us to submit semantic submissions to ClinVar. Next slide. So our workflow is a bit simplified for now, just because again, we're focused on new submissions to ClinVar. So really just given a GKS VA spec JSON file containing the AMP-ASCII-CAP community profiles, we can import our batch, submit the batch, and then retrieve the status of the submission. Next slide. So using our Wagner Lab organization, I was actually able to submit a few civic assertions to ClinVar using GKS ClinVar this. And in this example, it's just a therapeutic response assertion. Next slide. So now I'm going to talk about how we were able to integrate GKS ClinVar this in the civic workflow. Major shout out again to Susie and Adam from the Griffith Lab who led this effort. Next slide. So at a high level, this is going to walk us through the progress so far in the civic workflow for the staging environment. Next slide. So when endorsement of a SCV-SEP assertion happens in civic, next, the civic PI exporter gets the VA spec representation, next, creates the GKS JSON file and submits the endorsed assertion to ClinVar using GKS ClinVar this. Next, next, next. So we're able to make submissions using the civic staging instance and ClinVar test API. Next, next. We have not, again, handled how to resolve these errors in the workflow. Again, this will be addressed in the next steps. Next. And once the submission is successful, you'll be able to view 3-star records in ClinVar. Next. All right, next steps, go. 1 minute left. All right, this is something that Larry had created. He wanted us to highlight that ClinGen is doing work to support the ACMG v4 using VA spec. Next. So with that in mind, our next step is to support more VA spec community profiles. Right now, it's only AMPASO CAP, but we do have plans to support ACMG 2015 v4, the ClinGen CGC Vic 2022 oncogenicity guidelines, and there's also potential to support functional impact statements. Functional data is coming soon to ClinVar, and if they provide API support, then we will for sure add it to GKS ClinVar this. Next. All right, sorry that I'm over, but the main takeaways is that GKS ClinVar this accepts standardized VA spec input for scalable ClinVar submissions, provides a single maintained interface across ClinVar API changes, and this makes it so that any changes to the ClinVar API only need to be updated once by the GKS ClinVar this maintainers and not by each submitter. It also simplifies the submission for anyone already using GKS. So if you already have VA spec formatted data, you'll be able to easily submit to ClinVar. All you have to do is create a service count, get that API token, and provide a GKS JSON file for your data, and then you're ready to go. It also enables future integration with other tools and resources. So since ClinVar this, GKS ClinVar this uses the GKS format, it makes it easier for other systems to plug into the same workflow. And if another resource starts accepting GKS, you can reuse this logic you already have, which makes this approach scalable. Finally, next slide. I'd like to thank Alex, Larry, Matt for their hard work in VA spec, the Griffith team, especially Susie and Adam for helping integrate this work in the civic workflow. So I was the maintainer of ClinVar this manual for creating this amazing tool and being open to collaboration. And thank you to our funding sources, and no time for questions. What a shame.
All right. Thank you, Corey, and to all of our presenters for participating today. And of course, to all of you that came to learn about what we're doing here in GKS. As Corey mentioned, we're kind of running low on time for questions, but it is we're always welcome them. So please feel free to reach out with your questions to Beatrice. Her contact information is on this slide, and or shoot any of us an email if you prefer. And we look forward to having you participate either in future open houses or in our product development work streams. If you have a particular implementation you think is relevant to the work we're doing here in GKS, we'd love to hear from you. So get involved, reach out to Beatrice and let her know. All right, and with that, I think we're only a couple minutes over time. If anyone has any burning questions, I'm happy to stay on and address them. Otherwise, I'll just thank everyone again for their participation today and look forward to seeing you next time.
Thanks, Alex. This is great.
All right, people are dropping off. Thanks, guys. Appreciate your efforts running that.
Thanks, Alex. Good job.
See you later.